Have you ever wondered, from where do the clouds get their silver lining? How does water make such beautiful ripples? And how can you listen to the music on the TV even though you are in the kitchen? Well, think no more. The answer to this is diffraction. The phenomenon of diffraction is defined as the bending of waves around the corners of an obstacle or aperture into the region of geometrical shadow of the obstacle. Well, let me break this down for you. When a wave passes through a small gap or an aperture, it bends. This wave can be a sound wave, light wave, water wave, or any other wave of the electromagnetic spectrum. When Grimaldi in the 17th century originally described diffraction, he also stated some factors that affect diffraction. The first point is that diffraction will only occur if the wavelength of the wave, that is lambda, is equal to or smaller than the size of the opening. Let's go back to the beautiful skies and their silver linings. The silver lining is a result of diffraction. When the light wave from the sun, which has a very small wavelength, passes through the water droplets between the clouds, which also have a very small gap, they bend and spread out, resulting in the silver lining and the beautiful skies. Now, let's talk a bit about sound waves. One is able to listen to the music which is playing on in the living room even though that person is in the kitchen. How? Well, since sound waves have a larger wavelength and the wavelength is comparable to the size of the gap, for example, a door, the sound waves diffract and the music reaches your ears. This brings us to another factor affecting diffraction. It is the length of the gap or aperture. Taking the example of water waves, if the gap is large, just like in image A, then the waves produced are not circular. This means that there is less diffraction. However, if we move on to image B, where the gap is reduced, then some circular shapes can be observed. And finally, if we move on to image C, proper circular shape is observed in the waves, just like ripples in a water, and the gap is very small in this image. This means that diffraction depends upon the size of the aperture or the small opening. The reason for such circular wave after bending can be explained through Huygens principle. The Huygens-Fresnel principle states that every point on a wavefront is a source of wavelets. These wavelets spread out in the forward direction at the same speed as the source wave. Well, let me explain this in simpler terms. If you take a stone and drop it in water, circular waves will be created. This means that the waves are a result of the disturbance caused by the stone. So, Huygens stated that since the wavefront is a line made of various disturbances, hence each disturbance will cause its own circular wave, resulting in such various circular waves.